is to find an angle. And so this is written like this. Okay? This is the other version of the cosine rule. It is still the same rule, just written in a different way. The same with our sine rule yesterday. You have the A on the top over sine A, or you have the sine A on the top over the A. Same rule, just written differently. This is the same rule, just written differently, but this is the best version to use when we are trying to find an angle. And so this is a situation like this, where we've got three sides of a triangle. That's 5, that's 9, that's 10. What is this angle here? Okay, if I know that I've got a triangle and I know the side length to each of those triangles, without actually measuring, without actually drawing that triangle and measuring it, can I calculate what the angle is at any one of those corners? And the answer is yes, using this version of the cosine. So when I know all three sides of a triangle and I want to work out an angle, this is what I can use. Okay, so let's go through the steps for that one as well. Once again, it is important that we get our opposite angle and side identified. Okay, and so this is what we want to figure out. And so that's our A over here. And whatever is opposite that is the little a, lowercase a. And so that's my lowercase a over here. Again, it doesn't matter which one I call B and C. I'm going to call this one B this time and this one C. It doesn't matter which one I call B and C. They don't matter. It's the A's that matter. You've got to make sure you get the opposite angle to the side. And I've got to use the angle that I'm talking about, and then I've got to pick my side based off that. Does that make sense? Mm-hmm. Okay. So once I've got that, then I can go through and do it all again. So I say this. Let's write it out now. Cos, in this case cos theta, because that's what we're trying to figure out, equals b squared, 10 squared, minus plus c squared, 5 squared, minus a squared, 9 squared, over 2 times 10 times 5. Okay? Now this time here, I'm going to do kind of similar to what the question that was raised before. Without actually doing that calculation, I know that I need to get rid of this cos to find out what theta is. I need to shift the cos, and so I will do that even before I do the calculation in my calculator. I'm going to do the shift cos over here and the shift cos of all of that. So it doesn't matter that I haven't yet worked all that stuff out. I know that I need to do the shift cos, and so I can do that, and now I can type that into my calculator as one big equation. Let's do it to the nearest minute. So again, we're going to practice getting our answer. 63 degrees. How many minutes? Let's see how we go. What is it to the nearest minute? 63 degrees and how many minutes? So here's the question. So in my calculator it says, let's put this up over here, it says 63 degrees, 53 minutes, 46 points, blah, 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 seconds. Now, that doesn't matter. What is that to the nearest minute?
54.
Some say 53, some say 54.
54.
Why is it 54?
Because 30 seconds in a minute.
Well, 60,
This
which
is
is
30,
30 is the half.
yeah.
Half, that's exactly right. And so normally we're used to seeing something that's above 5 here, rounds up. That's because we have, that's like there's 100, we're talking decimals, we're talking 10 and rounds up to the next thing. But in our minutes and seconds, just like we have in time, there's only 60 seconds in a minute. And so if I had something that was 53 minutes and 46 seconds long, that's closer to 54 minutes than 53 minutes. Because 30 seconds is half a minute, and so we're above the half. And so that is 63 degrees, 54 minutes. Let me just check though, did everyone at least get that as their answer first? Okay. If we got that, that's good. Now just got to make sure we know how to round it off to the nearest minute. Okay, so they're the just two examples of the cosine rule, and that's using it straight from a triangle. But of course, with all of these things, that's one part of what we learn. But then we go there and then we get a situation where a car is travelling this direction for this long, and then whatever, and then we've got to use that, draw a diagram, and use the right rule for those.